effect.
Yeah, it's showing the right path.
Is it modern?
Yes, of course it is modern.
Oh, so it doesn't go straight to
Do you
it?
think we are selling classical experiments only?
That's the one.
Yes, that's it. So yeah, you see it opens with the default parameters. So let me explain what you see here.
So-
Exactly, right.
So we've got power going to either side of the magnetic coil.
Yes,
So that's
exactly.
generation of field.
Exactly.
We've got an
The-
AC voltage
Which is just the power supply for the
supplying that, right?
detector, right?
Where you connected the measurement
heating.
equipment?
It's connected via USB. There.
So this one will do all the measurement?
Yes. You do not need any
Cobra
additional
or-
Cobra, expert link, whatever. That's
They
it.
can do it by manually, we don't do it.
What's at 32.8 degrees?
We're too stupid. This house is easier.
What is at 32 degrees?
That's what's shown here. That's our sample temperature.
So that chip is at 30
Yes,
degrees,
exactly,
right? Okay.
exactly. So, but first maybe we should have a look inside the manual. What we should do there. So our experiment now is the Hall effect in NP germanium. We are doing with the PC. It has a difficulty of 3 out of 5. Preparation time of 1 hour. We did that already. And you will need 2 hours to do the experiment. So I hope we have some time.
2 hours means
I have an appointment with bowling alley.
just start for bowling.
Okay, yes. Okay, those are the tasks.
Why it's taking 2 hours, the preparation of the building
Because
of the system?
we are not that much experienced with that.
No, this is more or less average time. So when a student is coming in, he has to install software. And
But it's not like a
And-
process that
no.
you need to... Oh, okay.
And now with our new setup, it's even faster. You will see that. So we have different tasks measure the whole voltage as function of the current, or measure it in function of the magnetic field, of the temperature. Everything is included there.
Technical question.
Yes.
Why you have this wire that going outside of the...
we have a probe. A lot of customers have these probes available, and this is standard probe for magnetic field there. And so you just have to connect it somewhere. So we didn't want to take a Cobra 4 unit from connecting the magnetic field sensor there. Then include
This is a probe that go inside?
Yes. Yeah.
Oh, okay.
You can take it out.
Oh,
Just
this
see.
is what I asked.
Yeah, just exactly.
And this is a probe that measure
Yes.
The magnetic field.
the magnetic field.
Yeah. And we have also the tester meters standalone, and there you can use this sensor and connect with the tester meter with the digital display there and say,
Oh, yeah.
we have.
It's
Power.
matter the direction
Yeah.
that it's a
Yeah.
sit.
So when you turn it around, it's a minus.
Yeah, okay.
So you checked already what to do?
I was just quickly scanning through.
Ah, okay.
You want me to? Right, we're going to do task on then. Right.
That's task number 1, right?
There's no E. You've missed out the E on Tuesday.
Yes, I recognized that already.
In fact, on all of them.
Yes, of course. And we are doing it even in a
At
different
least
way.
there
We are not taking steps of 5 milliamps as well, so just automatically. Yeah. So yeah,
Can you
okay.
do it bigger, the zoom?
Yeah, sure. Go there.
Okay, so what is the next first step?
We will certainly only make task 1 and task 4 altogether. So
Choose a whole voltage UH and the current
Go to
IP
one
and the
and
magnetic
five,
field tester as measurement
which is the
parameters
temperature
from the
dependence.
start screen.
Yes.
1 and the last.
So this.
Where's my menu?
Yes, printed version.
All right, okay, that will help.
So we want to measure. No, first we want to set the current zero. So magnetic field zero, current zero means this one there.
Oh, right.
Alright, you have it. The value.
And you can change the display there and have the value there as well.
Exactly, you can also see it there. Now it's zero. So there are two little knobs on the back of the instrument of the unit. So now it's almost zero, right?
Okay.
So then you should set the hall voltage to zero.
Hall voltage.
Yeah, this one.
All right. Why are we not measuring anything here?
Yeah, it's done directly by this unit. Okay, great.
That's the red one then, is it?
Yes.
Mm-hmm. Yeah.
So then we want to have a magnetic field of 250 millitesla. This one. Therefore you have to higher the voltage there
250.
to increase the voltage. 250.
Okay, are you ready?
Yeah.
Still working.
We are still
But
working.
5 o'clock is it? No, final
Yeah, but
time.
Katinka, she's the boss. She told me she wants to give certificates.
I don't know. Give us 5 minutes. Then we're early.
5 minutes?
5.
I will ask her, you know.
So,
I don't know.
okay.
I'm
That's
not
fine.
the boss.
Tell
That's
her
fine.
we need 5 minutes, point.
Our measurement is that we want to take hall voltage as a function of the probe current from minus 30 milliamps to plus 30 milliamps. Which means now this one again. Now let's go to minus 30.
Okay.
Wow. Like this, that's fine. Start the measurement and just go to plus
Plus 15?
Sorry.
30.
30.
In steps.
No, just continuously. Not measuring anything. Ah, there it is.
Vier Minuten.
4 Minuten, 2 Minuten.
Nee,
Wir haben
bis
gesagt,
um,
eben 5.
bis um 5.
There we go.
That's it.
Right.
Inge hat mir gerade 2 Minuten gesagt.
So we've changed the current.
Current which is going through the probe. Okay?
Right.
Yeah.
And the other parameter that's changed is the voltage. Okay.
Okay.
So not,
Right.
if you now change, for example, also the magnetic field there, just turn a bit and make it again.
This
No, and the
Magnetic
power
field.
supply.
Oh,
So
Voltage.
No, the voltage. Maybe 100
Or higher.
or higher. Okay.
Well, and repeat the measurement. So go
Okay.
down a bit again to minus 30.
but going down with this, no?
Yes,
Yeah.
exactly. No, let's keep it like this.
Oh.
And then, wait a minute, I just start the measurement. So, yes.
And you see there's another slope. And this gives you then the parameters for the germanium then, and then you can calculate number, density of holes and electrons and so on, having it in the data available. So this is the physics behind what we are not doing here now.
why is it not going through the origin? With no voltage or with no
didn't-
current, you wouldn't have any voltage, surely.
I guess we have to the magnetic field.
Sorry? If we've got no current going through generating the magnetic field.
Of course there is a
Oh no, there is a magnetic field.
Yes, exactly.
That's
That creates
set by
you this offset.
Right, we've got we've got a fixed magnetic field. Right.
Exactly. So that's one way of doing the experiment.
Mhm.
So voltage,
Can I,
voltage current dependence.
if I want now to switch the color of one of the line, can I do it or I need to do it before?
You need to switch off.
The color. Just want to see one is blue and one is yellow.
Move on. I think yes.
Oh, sorry.
Signal.
Mhm.
No, it's not. Yeah.
It's possible.
Yeah. Now, last experiment.
Yeah, because Katinka's doing some. Okay.
Test. You to pass.
Exactly. Exactly, the test. For the
Otherwise, you will
certificate.
get certificate. Yeah.
So right now what we want to have is we want to set the current to 30 milliamps plus 30 milliamps. This one there, exactly.
Current.
No, it's not current.
Sorry, minus 30.
Yeah.
No, plus.
Plus.
And the magnetic induction should be around 300 millitesla. Again, yes.
Yeah, that's good.
And we want to determine the Hall voltage as a function of the temperature. So you know how to do that?
So I'm selecting.
Yes. Hall voltage is a diagram.
Is it diagram?
Temperature as a diagram.
Yes, it is. So and no, it's another one.
Sorry.
You can close the second one. It's almost the same as the first one. So and now we want to
So, hang
include
on.
their temperature.
Hang on, but that's showing voltage against time.
Yes, exactly.
So there was a configure. Configure me.
Shall I show you how to do that? You just go there and then drag it there. So now it's in the graph and you can decide what is on your X and Y scale. So the Y scale you change by just clicking there. And if you want to change the X scale, you have to go there and choose temperature.
Can you make that full screen then?
Yes, you can do.
Arrow?
No, click there somewhere in the upper bar and then no, hold it. No, the left one and make it bigger. Yeah, that's it. So now we want to do the temperature measurement. Therefore you have to start the measurement and, let me tell you first, push the button at the back with the temperature.
So
After he push.
Go.
Yes, just push it. Then it automatically heats, and if you now see the temperature, you see that it's increasing.
Until
So-
when?
Yeah, it's increasing up to 140 degrees.
Where you tell them?
No, that's just the default. You cannot change it. So that's the highest.
But you can stop now, and then it's maximum is 140. This is maximum.
But it will switch off automatically at 140. Then it's a little bit more increasing up maybe 5 degrees more, and then it's again cooling down.
Okay. So this is the curve, and you can have the other curve by cooling the system just by air. Then you will have two curves there available. So now you see it will stop in 2 seconds. 2, 1,
Now
stop.
the heating is off.
Then it goes on.
So what is that actually telling us then? So we had a minus 80 volts.
I guess that was just the switching. When I touched the unit.
But so it's